I think is where we got up to. Okay. Now let's just get our brains back into gear. We've got a point and it's equidistant from. This is the last scenario we did down outside. You know? We've got a point and we've got a line, equidistant. Because you've got a line in there, that's why we threw in the perpendicular distance formula, which admittedly is a bit tricky to remember. But if it encourages you, because the point perpendicular distance formula, right, has a point and a line that you feed into it, right? The line's here, got it in general form. The point, at least when we're dealing with locus, right, is always going to look like this, x, y, right? So once you put this into that form, that's your x and that's your y, and that, you just put it there, okay? So even though perpendicular distance is a bit hard to remember, at least there's not much you actually have to do which is new, okay? So, sure. If you haven't already, start simplifying that. It's not as hard as it looks.
Simplify what? That's all. Maybe I like this one.
It's disappeared.
No, she's punched last. That's good. Well, like, well, there's no doubt about that. Oh.
You can probably go get them.
Please, no. You.
Have you paid?
You are kidding me, man. I'm gonna stab someone.
Whoa. Whoa, crap. Dude, bad enough.
I said that like for the whole of last year.
Joking.
You know the mic's on. What, right?
I'm not telling you now. So it has to be.
Lightly tap you on
Is
the
it 1
shoulder.
minus 1 or 1 minus 1?
So,
How about this? 1 minus 1 could be plus or minus.
whoa, this is rough. What the hell, man? Crazy. I bet this is
Probably just one of them.
head of
I'm confused.
Okay, I'm gonna have to cut out like 10 minutes. That's fine. All right. Are you done? Are you done? How many answers are there?
What's
going on?
positive or negative?
Good question. All right, yeah, all right. Lots of questions. All right. What are all these questions coming from? They're coming from the fact that we've got distance, and they're just positive, right? But actually, in coordinate geometry, you sort of can have negative distances, right? Because that's why we've got this whole part of the axis which is negative, right? So you can go in a negative direction. So that's why the next step I'm going to do is I'm going to square everything. And that's going to, one, solve the square root signs, and it's also going to get rid of this pesky absolute value thing. Because if you square it, it'll come out in the wash. Okay, so let's give this a go. When I square this, it'll be just without the square root sign. Okay? This will also be without the square root sign on the bottom, but it's just, that's just 1, right? So that's over 1. And this thing here, 0 log to x, y minus 1, that's all squared. You happy with that? I've just squared everything. Do be careful with your squaring, by the way. Later on, when you'll say, for instance, suppose I didn't say they're equidistant. Suppose I said the distance from the line is always twice as much. Okay? If I put a number there like 2, when I square everything, it's not going to stay at 2, right? But people often forget to square it and it becomes a 2 here. It should really be a 4. Right? Anyway, you'll look at those kinds of questions when you have a go at the worksheet. Breathe. Now, let's keep going. Okay? Now I can actually expand out. And there's no other options I can have to try and simplify this. However, you should be able to sort of anticipate. See how I've got y minus something squared and another y minus something squared, right? There's going to be a y squared here and a y squared here that will cancel. Okay, so this is going to neaten up, but we need to expand everything first. Okay, so let's give that a go. So there are my terms that cancel. I also have other terms that cancel too, actually, which is kind of convenient. So I'm going to lose all of those. They can go into vanish. And what am I left with? Let's say x squared minus 2x plus 9. I'm going to move that minus 6y. I'm going to add it to both sides. So plus 6y, that gives me 4y. Over here, and I'm just going to divide through by 4. Okay, so what does this mean? I haven't bothered to actually do any further work or look at the discriminant of this, if you remember that from last year. However, let's actually start to draw this up and see what's going on. Okay? So when you've got your set of axes there, the first thing you do is you put on the important geometric features that were described in the question, right? So I have my line, y equals 1, so that's going to be going across here. Sorry?
Okay, how does like the 4, like it's divided by 4, what effect does
Yep.
that have on the graph?
Yeah, good question. So if you had this line versus this line, how would you describe the difference? Well, this one is flatter or more shallow than this one. Okay. In the same way, if I took a parabola, it's just going to be flatter. And if you went back to say trig, right? The difference between this and this is we call it amplitude, right? So it's the same thing, just squashed down. Instead of going from 1 to -1, it goes from a quarter to negative. That's it. Okay. Okay, good question. Now, there's my line L, right? So L. Okay. Where's my point? 1, 3. So 1, 3. I suppose I should put that there. Okay, now, just picture, do you remember where we were standing with relation to the wall, right? Without knowing anything about, what its intercepts are, blah, 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 what would you expect this to look like? Well, you can all know, where's the lazy spot to stand, right? Exactly halfway between the point and the line, the wall. And we give this spot's so important, we give it a special name, it's the vertex, right? And then the rest of you sort of moved off. What's that? So it looks something like this. Okay, and there's Jesse, because he was off on the side, right? And everyone was going back and forth and back. So having a look at this, this is me just interpreting it geometrically without looking at my equation. Okay, but now you could go and you could include, for instance, that if you went and did the discriminant for this, what kind of value would you expect the discriminant to have? The discriminant tells you about roots, right? Whether you've got them, how many you've got. I have no real roots here, right? So that would imply the discriminant is negative, okay? Something like that. And it'll save you from wasting your time trying to find roots because they won't exist, or they won't be real anyway, so you don't need to graph them. What's this point here, by the way? Curious. Can you see it? Can you read it off? It's just 9 on 4, right? Because when you put x equals 0, these guys just vanish, and you're left with the constants. 9, 4. Ta-da! Done. Okay. Now, on the sheet, I'd like you to have a go at these. Again, be careful. When you read this, you want to start by identifying the key information. You can either circle it on the sheet, or I like to write it down because it helps get into my head. Okay? And then the first thing you should always write after that key information is the equation that defines it. So far, we've just been saying this equals that. Okay? But it might be this is double that, or this is this plus 1, or something else. Read it carefully. The question will tell you. Okay? And then you can launch into, all right, that's a point-to-point. So that's the point-to-point formula. That's point to a line. So use that formula. Okay? And that'll tell you where to go. All right, off you go.